Equations of tangents and normal lines. Do you know what a normal line is? We know what a tangent line is. What's a normal line? Is that something you've taken in physics? No? So if I have x squared, and I take a point on x squared, this would be the tangent line at that point. The normal line is the line that's perpendicular to the tangent line at that same point. So if you wanted a normal line, you could find your tangent line first. The slope would be the negative reciprocal because it's perpendicular. So with equations of tangents and normal lines, what we can do is we can use calculus to help us find those equations. Because if we have a question that says, find the equation of the tangent line at this point on the curve, we could do calculus to find what the derivative is. And the derivative is the equation of every single slope of every single tangent line on that curve. You could plug in the specific point you were looking for to find the slope of that specific tangent line. Then once you have the slope of that tangent line, then you could use your skills from grade 10 to find the equation of the line, either using y equals mx plus b or the point slope formula. So you can use the point slope formula or y equals mx plus b to find the equation of the line. Do you remember that point slope formula? Some yes. Do you remember y equals mx plus b? Which one do you remember better? Y equals mx plus b. So if you remember that better, perfect, you can use that one. And I'll show you how you could use either one of them, either the point slope formula. In equations of lines, how do you find slope? What is slope? This is not supposed to be here. Rise over run. So, okay, just a little bit of review. Would you agree that your rise, do you remember your slope formula from grade 10? y2 minus y1 and x2 minus x1, your rise over your run. What if I rewrote my slope formula so I didn't have any fractions? What would I have to multiply by? x2 minus x1, right? So then I would get, this is just my slope formula rewritten. What does your point slope formula of the equation of line do? It says plug in one point. x1 and y1 are your one point. And your other one just leave as x and leave as y. There's your formula. Your point slope formula, all it is the slope formula rearranged. And instead of having 2 points that you plug in to find your slope, you know your slope and you leave 1 point as x and 1 point as y. So maybe that helps you remember your point slope formula from now on, because you know what your slope formula is. So we want to find the equation of the tangent to that parabola at x equals 1. We want to write our answer in y equals mx plus b form. So first of all, we could find the derivative. The derivative would just be 4x. Once we have our derivative, we could say, I know that at x equals 1, if I plug that into my derivative, I get 4. The slope of the tangent line at x equals 1 will be 4. And once you have a slope, we have the slope of our line, and a point. What's the point that we want to find it at? 1, comma. If I plug in 1 into my actual equation, my point is going to be 1, comma 5. And to find any equation of a line, you need those two things. You need the slope and you need the point. Once you have the slope and the point, this is where you have a choice. You can either use the point-slope form, okay? Y minus y1 equals mx minus x1. The nice thing about the point-slope form is it's usually quite easy to rearrange and write out. So you would get y equals 4x plus 1. Here's a picture demonstrating what we just did. If you didn't want to use the point-slope form, you're like, Mr. JR, I remember y equals mx plus b so much better. If you wanted to use y equals mx plus b, well, we know the slope is 4, and we know one point. We know that when x is 1, y is 5. If you plug in the point and the slope, what could you solve for? You could solve for b. And from here you would get, oh, subtract 4 on both sides, b is equal to 1. So what's my equation? Y equals 4x plus 1. And that's perfectly fine as a way to do it as well. So you can use y equals mx plus b, plug in your slope and your point to find b, or you could use the point-slope form, plug in your slope and point and rearrange it to get your equation. I'd like you to try the next one on your own. I'll put up the answers so you can check along the way. Did you get your derivative correct? Did you find the right slope of your tangent line at that point? Did you find the point on your line? Mental math. If you had to do this, square root of 4 to the 5, I would suggest not doing 4 to the 5 first. I would suggest instead, okay, this is the same as 4 to the 5 halves, right? You can choose to do 4 to the 5th first, or you can choose to do the 4 to the half first. 4 to the half is the square root of 4, that's going to be 2. And 2 to the power of 5 is going to be 32. That's a little bit easier mental math than trying to do square root of this, which is, what is that, 4 to the 5? 1024? Yes. And then here in part 4, you can either do point slope and rearrange it, or you could have done y equals mx plus b and solved for b. You know the slope is, was it 4? Slope is 20. The point that we have, x is 4, y is 32. And solved for b. Either using the point-slope form or y equals mx plus b would be fine. A picture of what we did. There's the graph, and we drew the tangent line to that graph. So once again, don't just, like, I know that you could remember how to do these questions, but every time you do a question, try to think about what does this mean? What are we actually finding? How does this connect to each other? Because the more connections you make that way, the deeper your understanding of what we're doing will be. And on the IB exam, they like to create questions that test, do you really understand what's going on? Or are you just memorizing how to do things? If we make a question like this, every student who's just memorized how to do it will get this question wrong. But every student that understands what's going on in the background to this question will be able to figure it out. And it's not that bad. So we always want to try to understand what's going on. Think about, what did we just figure out? And we don't have it yet, but eventually be like, why would we want to figure that out? How does that help us? Two tangents to the curve y equals 2x squared. The two tangents to the curve y equals 2x squared at the point where y equal 8 meet at the point P. Find the coordinates of this point P. So if we draw a picture, and this is, again, one of those examples, it's a little bit different. If we draw a picture of what's happening before I open up any boxes, 2x squared is a parabola. At y equals 8, does it make sense that there are 2 points on the graph where the y value is 8? You could draw a tangent at this one, and you could draw a tangent at this one, and eventually those two tangents will intersect. We need to find the point where they intersect. How do we go about that? And what could we do? Well, we could find both of those equations, right? We could find the equations of two lines. We know that our derivative of 2x squared is 4x. We have a point 2, 8 and negative 2, 8. So at x equals 2, can you see the slope of the tangent is going to be 8. At x equals negative 2, the slope will be negative 8. I'm going to call this tangent line 1 and this one 2, just so that we can follow in our notes which one's which. So we have one with a slope of 8, one with a slope of negative 8. From here, we could do, if I want to do equation 1 in y equals mx plus b form, I know that my slope is 8. I know that my point is 2, 8. And I solve that y is equal to negative 8. So in y equals mx plus b, the equation of line number 1 is 8x minus 8. I could do the same thing with equation number 2. My slope here is negative 8. I've got the point 2, negative 2, 8. And solving for b, I get negative 8 again. Now, either fortunately or unfortunately, our work just got really easy. Where do these two lines intersect? At when x is 0 and y is -8. Can you see that they both have the same y-intercept? They intersect at 0, -8. Now, I said it's either fortunate or unfortunate. Fortunate if you want your question to be over, right? Because it's really easy at this point because you can see where they intersect so easily from the graphs. Unfortunate if you were excited about doing some more math and now you can't because you've already figured it out. That happens sometimes. So the question is, if this didn't work out nicely, what would you do? What would you do if you wanted to find out where two lines intersected? Yeah, you could use like substitution, make them equal to each other, solve for x, and then find out what y is. I mean, it's a little bit more work, but it's important to know that it's a systems of equations question that comes up in the middle of this question, where you would have to find out, how do I make two graphs, find out where the two lines intersect? I could make them equal to each other, and then solve for x, and then when I solve for x, then I could plug that back in and solve for y. But in this case, it was straightforward enough that we could solve directly. Example 4. Find the equation of the tangent line to that function and one that is parallel to the tangent at 4, -21. So there we have a graph of what's happening. For part 1, find the equation of the tangent to f of x. They're just asking you to find the derivative. And then 2, if we find the one parallel to the tangent at 4, -21, we have the derivative, plug in 4. We're going to find out the slope is 11. Plug that in. Here we're using our point slope form. We could find the equation of that line. And sometimes a question like this on an exam will say, are there any other tangent lines on this graph that have the same slope as that one? If I drew that same tangent line, is there anywhere else on this graph you think there will be that tangent line? Maybe right about there? Looks like it could be a possibility. What's that point? How would we find that? Okay. This is a typical type of question that you would get as a part 4 to this. You found the derivative, you found your one equation line. That's your standard stuff that you need to do, and now we're causing you to think. What do you know about this line? We know the slope is 11. So what we have is we have an equation for all the slopes. F prime of x equals 3x squared minus 3x minus 13. We could use that equation and say, I know the slope is 11, I just don't know what the values of x would be. How would I solve this? Move my 11 over to the other side. Okay. Can you see that you could factor a 3 out of there? That'll make your factoring easier, leaving you with x squared minus 2x minus 8. This factors to be x minus 4x plus 2. Does our x equal 4 answer make sense to us? Look at the graph. That's this point, right? When the slope is 11, one of the points is 4. What's our other point? -2 comma something. How would I find that comma something? Where would I plug the -2 back into? Here, 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 where? We'd have to plug, if this point is where? That point is on the original function, right? So if I want to find the coordinates of that point, I'd have to plug it in to the original function. So -2 plugged into here will be -8 minus 12 plus 26 plus 15. -2 comma positive 21. Whew. So that's a part B to this question that often comes up on an exam. Can we take something that you know and make you think about it? The slope is 11. There's another point on this line where the slope is 11. Where is that? All right. We are going to leave end at this question.